So let's look at what it takes to make the mass and cost budget content work. So again, this is our BDD showing our subsystems and the blocks that make them up. And these are the customizations that drive them. So the physical stereotype carries mass and mass budget, which should be set at the class level effectively. Same thing for cost and cost budget. And it carries the electric power usage that is used by the power scenario. But we also care about rolling up these masses and costs and comparing them with the budget or the allocation. So we want to put some simple rules in place. So we need a mass rollup and a cost rollup, and we need to calculate the mass reserve and the cost reserve. So we'll start with the mass rollup, and the cost rollup works exactly the same way. So notice we have a derived property specification here for the mass rollup, and it's using an if-then-else expression. So we have a rule we've put in place here. And again, we're using a lot of fairly straightforward logic that really, again, once you articulate it, it's fairly straightforward to do it in the tool. So the first thing we check is if we don't have any part properties. So you don't own any subparts. So this is an isEmpty check. We're looking at your members, so you could inherit some. So we're checking not just the owned members, but all members, and filtering by part property. So if you are empty, if there is no part property, then we use the first relationship to return a number, and we go from you to your mass. And so if you don't own any parts, the mass number in the tag is what we use. Otherwise, we have a reduce operation that is using the custom map for lists that returns us the list instead of a collection, and I intend to update this with some product in the near future. But fundamentally what this is doing, and notice the use of context elements and other things to make this work, this is the sort of thing that will reward careful study outside of the scope of the conference. But to walk you through it in general, what it's doing is if you do own part properties, we go ahead and we return them. So that's the input to the mapping for lists here. And then the mapping operation goes ahead and it multiplies your upper bound or your multiplicity in the context of the part property times the mass rollup of the block that types that. So we're now tying the mass and the multiplicity and multiplying it by the mass rollup property of the block that types the part property. And then we had the reduce operation then sums those up. So again, I intend to replace this with some product. So fundamentally, this is either the sum of your part masses or your mass. And that's what gets placed into the mass rollup property. The same thing happens for the cost rollup. And then the reserve is simply a matter of taking the difference of your, and this is a JavaScript, it's just the mass budget minus the mass. And so mass budget is the first, returning your mass budget value, and then a first operation to return the mass rollup value. So again, same thing for the cost. So those two work fairly well together. The nice thing is if you have this displayed in a table and you make a change, that row changes and a simple refresh updates the entire model. My previous efforts to do this ran scripts. By having it as a derived property, it makes it all update automatically. There's also a property group here called swapC, and that's a very handy feature that I encourage you to explore. I've basically created a swapC property group and included all of these so that way they show up on the block. So if I open up the specification window for subsystem A here, notice that I have swapC over here on the left, and I can just view all those elements or all those properties in one place, which makes it very convenient. So if you're going to do customization, consider creating nodes for yourself so they show up in the tree off to the left. You also can view them here, and they appear down here in these properties as well. I customized it with the properties to have these show up in expert mode. So if I look at my table, we now have a table of the masses. And let's take a look at what this is telling us. So the first thing I did is I created a check column here just for debugging purposes. And all this is doing is it's a not operation, is empty, and looking at the member part properties. So basically this is converting to a Boolean, and then I wanted to flip it. So basically if you don't have any part properties, you should be false. And so that's why there's the not involved. So this basically lets me have a quick double check that if there's a true, you shouldn't have a mass, you should just have your mass roll up. Notice that the mass budget, mass reserve are calculating here. Same thing with the cost and cost roll up, and I was just displaying the electric power usage off to the right just because. I also have a dynamic legend in place here. And what it's doing is if you have a negative reserve, it's turning it red. And if you are within 10% of your reserve being exhausted, it turns it yellow. So notice if I change my mass budget here from 10 to 11, I should lose the, probably 11.2. It should no longer be yellow here. So again, there's just some things you can do here to, again, help yourself out and do some color coding. Now notice here, if I change my mass from 20 to 50, this updates instantly. And then if I hit a refresh here, the entire model now updates, the entire table. So this is working just fine. And again, I encourage you to experiment and debug, and please give me feedback. I do want to show how I made the dynamic legend work. It's been defined here and is applied to this table. And there's basically 4 separate elements that are being dynamically applied. And so if we look at the legend items here, I'll look at the mass overrun, for example. Elements by condition, and then it's adorned to a specific property. And so you have to be careful and make sure you set this up correctly so that that's visible. And you can select it. In this case, it's less than, and I just return the mass reserve. And if it's less than 0, it goes ahead and turns the cell red. And there's a computation in there for determining when to turn the cells yellow. I would point out that we have a quality check in place so that if this has a mass, it doesn't immediately throw an error. Notice that it does ignore it. The mass budget's totally driven off the roll-up, and our logic ignores this. But we don't want to leave this condition in place, and so our quality check scripts will help us find this. Rather than put the code and complicate the code for the mass calculations, I chose to catch errors like this with a validation suite that we'll explore in the next video.